Hello everyone. So today, let's solve the problem number 752. Open the log. Yeah. So let's see what the question states here. So we have a 4-digit log starting from 0000. Yeah. We have see here. We have a 4-digit log starting at 0000. Each move rotates one wheel up or down by one. Right. When I say each move rotates one wheel up or down by one, it wraps around 0 to 9. Yeah, some codes are this one dead ends that cannot be passed at all. Yep, so just keep this in mind. We have to return minimum moves to reach the target, or if it is impossible to reach the target, then in that case we have to return -1. So that's what the question states here. So we have been given target here, right? So this is fine. See here, let's consider the example one here. We have 0201, 0101. So this one 4, 5, right? Target we have been given 0202. So a sequence of valid moves would be, first we will be starting with a, as I've said, this one we have 4-digit lock starting at 0000. Yeah, 0000. Then what we will do, this one. Next we will be going with a 1000. Yeah. Next we can just go with double one. Next step actually 1100. Then we can change the this one to 2 here, right? So we can just go with 1200 as well. This one, the fourth step actually. The fifth step here would be, so here at the end we can just go with a 1201, and finally here we can just go with a 1202, right? So 1202, finally we can just change this one, the last one, to the 0 here. This will lead us to the 0202. Note that the sequence like this one 0000, this one actually whatever the sequence that they have given, so this one is invalid. They have said 0002, 0102, 0202. So this would be invalid because the wheels of the log becomes stuck after the display becomes dead end 0102 actually 0102, this one. Yep, they're strictly mentioned in the question. I hope this is clear, man. Next, let's go with the second example. They have given here double eight here. So target is 0099. So 0009 actually. So output here 1 because we can turn the last wheel in the reverse to move from this one 00. So the last wheel will be turning this one to the 9, right? So we can just turn the last wheel in the reverse to move from 0000. All we have to do is this one. We can just turn this one to the 9, the last digit. Yeah. So here we have turned. So see here, we have turned from 0000, starting from the 00. We have started from 1. So again, this one, the second number, we started from 1. The second number we changed from 1 to 2. The next number we can just go in that way as well, right? 1, 2. The last number we started from 1. This is fine. 1202. Next, the last number we this one. The next number we considered this one 1202. Finally, we reverse this one. The last number actually 1 2 actually 0 right? That is how we got for the first one. The second one needs only one actually, only one this thing. One move actually. We can turn the last fill in the reverse to move from 0000 to 0009. Yep, so this is fine. Next, the third one is dead ends. So we have been given this one actually, and the target we have been given 888 So this is impossible here. We cannot reach the target without getting stuck here. So output in that case we have to return -1. I hope this is clear, man. Simple one. Yeah. So now let's do one thing. To solve this problem, so we can just go with a graph, I believe. So let's do one thing. One second, just give me a second here. Yeah, let's go with a BFS to solve this particular problem. Yeah, let's go with BFS to solve this particular problem. Yeah, let's see. Let's discuss this one step by step. Let's do one thing. I'll just remove this. Let's consider the same first example that they have given in the question for the approach as well, right? So we will be going with the DFS, sorry, BFS. Just remember this one. So the first step here would be, so one thing here, we have to model every 4-digit code as a node in the graph. Yep. So as we are considering this one as the graph, so let's model every 4-digit as a node in the graph. And edge connects codes that differ by one wheel move, right? Each node has up to 8 neighbors, we know, right? +1 or the -1 for each of the 4 wheels. This we know. Yep, accordingly with the question. Now what we will do, we'll start the BFS from 0000, meaning initially keeping the level to 0, right? So finally, we'll mark the dead ends as blocked and never enqueue them, right? So let's apply the same thing on the example. You'll come to know. See, first, let's go with the level 0. The same thing, let's consider the same thing here. So let's go with the level 0 here. So see, initially, let me consider level 0. L0 is nothing but the level 0, right? Level 0 initially will start with the this one, 0000. Yep, initially. Yep, so this is fine. Next, let's go with the level 1 here, right? Level 1, right? Level 1 here, we have neighbors like 1000. 1000. We have neighbors like for the 00, this one 0000. We have neighbors like 1000. Also, we can just consider reverse the first one, right? So that this is also one of the neighbor 9000. Also, we can just consider from the second number itself. So that will be 0100. This is also neighbor, and we can just start from 9. We can just reverse the second number as well. This will be 0900. This is also one of the thing. And we can go with the third number. We can start with a 0100, right? And so on. So 0900, and for the last number. So and so on. We can just check it out in this way for the level 1, right? So we only enqueue the valid ones, right? So we only enqueue the valid ones. Here in this case, we will be choosing the first one itself. Yeah, we will choose 1000 here. So chosen here. So CH, it is nothing but the chosen. Chosen one is 1 followed by the 000, right? So we have chosen this one 1000 in the level 1. Now let's go, or let's move on with the level 2 here, right? Level 2 actually. Level by level, because we are making use of the BFS. Yeah, don't get confused here. Level 2, we will be going with a 1000. Similarly, we'll be checking for different things, and we will choose here from this one, sorry, from 1000. So we can just go with a 1100. Next one, we will this one rotate. So we will be considering 1, or we can just go with a 9 as well. In this case, we will be going with a 1. Next flip, yeah. So we'll flip the 0 to 1 here, right? The 1 1, we will choose this one, the chosen one for the level 2 here. This one is 1100. Yep. This is fine, I believe. We'll check for everything, but we will be choosing. So this one 1100 basically, right? So the same thing, what we will do at the fourth step. So we'll continue BFS layers until we reach 0 to 02. We'll continue the BFS layers until we reach 0 to 02. Yet, right? At level 6, following the shortest sequence here, the shortest sequence here is 0000 followed by 1000 here, 1000. This is also fine. Followed by this one 1100, followed by this one 1100, and followed by this one 1200, 1200. This is also fine, and followed by this one 1201 actually, 1201. And next we will be selecting 1202. Next we will be selecting 1202. Finally, we can just this one reverse this one, the last one, the first digit actually. Sorry, when we reverse, it will be 0202, right? So here, basically, BFS guarantees the first time we pop target is via the shortest number of moves, right? So minimum turns. So in this case, minimum turns, you can just go here from, we have started from this one, 1, 2, 3, 4, 5, as well as the 6. It took us 6 turns actually, right? So we'll count this one 6, and we'll return this one as the output. So how many turns we have to move on with? So basically 6 turns, right? So this one we will return in the form of output. So the output that we got here is 6, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So this is how we will be making use of the BFS man. Yep. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part here. Right, let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n. So why it is big of n? So in the this one constraints we have been given n less than or equal to 10,000, right? Here it will be big of n because in the worst case we visit every code and generate a constant number, nothing but 8 of neighbors each, of eight of neighbors each, right? So overall time complexity would lead to big of n. So what would be the space complexity here? Space complexity would lead to big of n as well, just to store the visited set and queue in the worst case. So overall space complexity would lead to big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Now, as we are completely familiar with the approach as well as the complexities part, we are good to write the code. Let's start writing the code. Yep. So the first step, let's convert the deadends array to the hash set for big of one dead checks, right? So I'll just go with a set here. So let me convert this one to the string. I'll just go with a dead set here, new. Let me go with a hash set. Also here, let me pass. Uh, so I'll just go with the arrays as list. So this is fine. Of I have to pass this one, I think dead ends, I believe. So let me do one thing. Mm, Let me copy this one dead ends and let me paste it over here. Right. So now, one second, what happened here? Yeah, we have successfully converted the dead ends array to the hash set for just this one. Big of one dead checks actually. Yep, this is fine. Simple one. Next, let's move on with the further things. If the start itself is a dead end, then we are stuck, right? Then we are stuck. Immediately we have to return -1 in that case, right? So let's write the simple if condition for that. So I'll just go with the dead set here dot contains. So if it contains 0000. So where am I writing from? Yep, let me hit the enter here. So yeah, it's 0000. Then what we need to do here in that case, we have to return -1. So this is fine. So now we have successfully written the if condition, right? If start is a dead end, we are stuck immediately. We have to return -1. So this is fine. Now, as I've said, we'll be making use of the BFS, right? So let's go with the BFS queue just to hold the frontier nodes, right? Nothing but the codes. It has to hold the codes, right? So I'll just go with the queue here, queue of let me pass the string. So this is fine. Let me go with queue. Let me assign this one to the new linked list. Yep. So this is also fine. The next one is let's add the visited set to avoid the revisiting. To avoid revisiting the same code. So let's go with the set here. Go with the set. Let me go with the string. So let me go with the string. So this is also fine. Yep. Let me go with the string. Q equals new. Let me go with linked list. So this is also fine. Let me complete the syntax here. Yep. So after this, after selecting the after this one, making use of the BFS queue just to hold the frontier nodes. So what we did actually, we visited. So we went with a visited set to avoid the revisiting the same node. Now this is fine, man. Now let's do one thing. Let's initialize the BFS with a start code 0000 as they had said in the question, right? As this is one of the criteria that we have to start with 0000. Let's initialize the BFS with a start code 0000. So I'll just go with q dot offer here. So let's start with 0000. So this is fine. Yep. Now let's do one thing. Let me go with visited actually visited dot add the same thing actually 0000. Yep. So this is fine as well. Now the main thing, we have to go with the number of moves taken from 0000, nothing but the BFS levels accordingly with the approach that we discussed. So initially let's initialize the steps to 0. This is fine. Let's go with the standardized BFS loop. So I'll just go with a while of not this one q dot is empty. So this is fine. So let's process the current level size, this one nodes, nothing but all codes at the distance steps, right? So I'll just go with the int size equals. So this one will be q dot size. So this is also fine. Yep. So the next step is let's move on with the iteration pattern. So this one will be for int I equals 0, I less than size. So let me increment the I here, right? So this is fine. Yeah. Now let's pop the current node. So I'll just go with the string here, current. So this one will be q dot poll. Yep. So this is also fine. Now, if it's the target, if this itself is the target, then we have to return the distance, nothing but the steps. So let's write the simple if condition for it. So this one will be if current dot, let me make use of the equals here, equals of target, then let me do one thing. Let's return steps actually. Let's return steps. Now let's generate all the neighbors by rotating each of the four wheels +1 and the -1. Let's move on with the iteration part. One more for loop here. So this one will be for in position equals 0 initially, position less than 4, then let me go with position less plus. Yeah. So within this for loop, let's convert to the character array just to mutate a single wheel. So I can just write it in this way. So this has to work. Let's see. So this one current. So I'll just make use of two char array here. So I hope this works. This has to work. Let's see. Yep. Now, mm, let's go with the current digit character first. So I'll just go with char c equals array of. Mm, Let me pass the position p voice, right? So this is fine as well. Now let's compute the digit values from 0 to 9. So this one will be int digit equals c hyphen 0, c hyphen 0. Yep. So this is fine. Next, what we have to do after doing this one, let's do one thing. Let's go with a neighbor by turning wheel up actually. Let's move on with a neighbor by turning the wheel up actually. This will be digit +1 with a wrap, right? So I can just write it in this way. Int up equals, so let me go with digit +1 here, modulo 10. So this is fine as well. So next, let's go with the array of position. So equals char. So this one, let me go with 0. Let me go with 0 plus up. Let me go with 0 plus up, right? So this is fine. The next step would be, so let's go with a neighbor string after upturn, right? So I'll just go with string. I'll just go with sup here. So this is fine. New string here. Let me pass the array here. So this is also fine. Yep. If not dead and not visited, then we have to add that one to the queue and mark them as visited, right? So I'll just write the simple if condition for that. So let me leave space here. So this looks good actually. So if not of basically dead set dot contains s up is the keyword that we have made use of, right? Variable name. And so not of basically visited, right? So I'll just go with 1 second. Let me copy this one, paste it over here. Visited dot contains, right? 1 second. Yeah, I'll just leave here contains of again s. So this is fine, I believe. Yep, so within the if condition, so let me go with visited dot add of the keyword sup that we have considered. And again, we have to it's if it's not the end, and if it's not if not visited, then we have to add to the queue and mark that one as visited, right? So I'll just we have marked that one visited, so we have to add. I'll just go with the offer of this one sup. So this one will be sup. So this is fine. Yep. So let me come out of this one entirely. Now let's do one thing. Let's restore the character array to current digit further. This one down more actually. So this one will be array of position. So let's assign this one to the C. And also let's go with the neighbor by turning wheel down, right? So digit -1 with a wrap. So this one will be int down equals. So this one will be digit +9. So this is fine. Modulo 10, right? So modulo 10. So this one will be array of position. Let me set this one to the char actually. Let me set this one to the char. So this one will be 0, 0 plus down, 0 plus down. Yep. So this is fine. Let's go with the neighbor string after the downturn. So I'll just go with the string here is down. This will be new string actually. Let me pass the array again here, right? So this is fine. Again, if not dead and not visited, then we have to add the queue and we have to mark that one as visited. The same thing, man. I'll just copy the same thing here. This if condition. Let me copy this one here. Let me come here. So I'll just leave a space and let me paste this one here. Uh, Instead of this one counts of this one s dot this one s up, I'll just go with a s down actually. Yeah. So s down is the thing. This one actually. Yeah. Let me copy this one actually. Instead of this one, visited dot contains down visited dot add of again same thing here also. The same thing we are doing here, right? So this is fine. Yep. Now, we don't have to explicitly restore array here, right? So whatever the loop that we have made use of, that loop will recreate from the current variable actually. So I don't have to write anywhere over here, anything over here actually after this one here. Actually. This is fine. After this one, let me come here. So the next step would be here. So we have finished successfully finished one BFS level, and then we have to increment the steps, right? So moves basically. So we have to increment in the sense I'll just increment the steps here. So this is fine. The final step here would be if the BFS finishes without finding the target, then it's unreachable. Then we have to return -1 in that case, right? So let me format the code and let me hit the run button. Yeah. So I hope this works for all the test cases. Man, what is wrong here? Variable queue is already defined in method open log string queue. Hmm, okay. 1 second. Set string. So this one we are making use of the visited, right? 1 second. Just a second. 1 second. Yeah. I'll just go with the visited variable. Instead of the visited, I have given queue here. Okay. Let me run the code once. What happened here? Incompatible types cannot infer type arguments for the linked list actually. Set this one again the same line. So what we are doing here, set string visited. Oh, this one has to be hash set man, not the linked list actually. Didn't I give hash set? Did I give? Okay, fine. This is fine. Anyway, let me run this one. Yeah, you can clearly see. Now the sample test cases are getting passed. So let me hit the submit button quickly. I hope. Hmm, hmm, Wrong test 45 actually. 45 test cases passed. There are three. So this one instead of the output 8, we are getting -1. So 1 second. So here we have to get the -1, but we are getting this one. So 8888. So we have to get the -1 they have given, right? So we have written the condition here. First itself, if data set contains double zero double. Oh, this one. Uh, 0000. Not I have given double O actually. Okay, fine. Let me hit the submit button directly now. This has to work now. Yeah, all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities part. Yeah, for now, this is it. Thanks for watching, guys.